Students, good afternoon. Students,
Yes, sir. Yes, sir.
okay. So today, I will discuss with you one important concepts. So the important concept is one is delay concepts, one more is compiler directives concepts. Delay concepts and delay and compiler directives. Okay, we'll see. When come to the compiler directives, what is the meaning of compiler directives? Compiler directive means compiler directives are special commands. Okay, so they are, yeah. So begin with CC. Begin with this is the symbol. This is symbol. Begin with quotation, single quote that affects the operation of the Verilog simulator. So directly, what happened? This directives will okay. So will affect the operation of the simulator. The synopsis Verilog HTML compiler, design compiler, and many other synthesis tools pairs and ignores compiler values. Plans can be included even in synthesizable models. The meaning of this one is, the meaning of this last sentence is, see, so whatever the compiler directives, of course, they are not synthesizable, but tools knows whenever it defines the compiler directives, they will ignore those words so that there is no issue with the synthesis process. That is the yeah, one of the compiler directives time scale. The time scale means the beginning of the program, we need to mention the time scale. By default, some settings are there. We are going with the settings. We are not changing the settings. That's why we don't have so to set the time. But there is a time scale. It must be the first line of any program. So if you are not mentioned this one, what happened? By default, settings will take place. Time scale specifies the time unit and time precision. Unit and precision. What is the unit and what is the precision? Precision is nothing but rounding of the values. Rounding of the values. A time unit of 10 nanoseconds means a time expressed as, say, suppose this is time, then 10 nanoseconds means this can be written in terms of like this 23.0 nanoseconds. Okay, so whenever you specify the time unit in 10 nanoseconds, okay, that must be right like this 10 nanoseconds by something precision value. So the first one means, what is that one? So rounding. Suppose this is the delay 2.3, which means 23 nanoseconds. So the next term is time precision. Time precision. What do you mean by time precision? So this specifies how delay values are to be rounded off during the simulation process. How delay values have to be rounded off during the simulation process. Clear? So the first one is time unit. Simply whatever the value is specified, it must be taken as integer and the units are specified as it is. 2.3 means 23 nanoseconds. 1 means 10 nanoseconds. 1 means 10 nanoseconds. Because 2.3 is multiplied with the 10 nanoseconds is equal to 23.0 nanoseconds. Suppose if you, this value, if in this place, suppose in place of 2.3, so if you have, suppose in this place, if you have ash 5, then the delay will be how much? 5 into 10 nanoseconds is equal to 15 nanoseconds is the value. That is the time limit. Time question is rounding of the delay values. Okay, so how rounded off the during simulation. Valid time limits includes, so time units, upper one, valid units are seconds, milliseconds, microseconds, nanoseconds, picosecond, and hectoseconds. This is the, so units, they are some, you can write any value. So 1 second or 1 millisecond or 1 microsecond, 1 nanosecond, 1 picosecond, 1 femtosecond, like that. So only 1 or 10, 50, 100, okay, are valid users for specifying the time limits or question values. It also determines the displayed time limits in display commands like what? $display. Okay, these are the compiler directives. Okay, so the first compiler directive is time scale. This must be starting line of the any program. So far we didn't mention this time scale. That's why the compiler automatically takes the default values. The syntax of this time scale is, see, we should write like this. So time, okay, scale, space, what is the time units by time precision. This is the way of you can represent. See, the time scale is 1 nanosecond by 1 picosecond is okay. 1 micro by 1 nano is also okay. 1 nano by, sorry, 10 nano by 1. See, here is 1 nanosecond by, okay, 1 microsecond is not valid. Is not valid. Clear? So that means the whatever the precision values must be lower values. Okay. Here is nano is more than pico, so micro is more than nano, and nano is more than, of course, this is also possible. Okay, this is also possible because this is more than this value. So this must be, time units must be more than the precision values. You should be, keep in your mind, you should write like this. You should assign the time values, time scale like that. Okay, this is wrong. 10 nanoseconds is the time unit, and precision value is, suppose 10 nanoseconds. This is not possible. This is not possible. This is wrong. See, another one is, another compiler directive is macro definitions. A macro is an identifier that represents a string of text. This is an identifier. Identifier means what? Name. That represents the string of text. Macros are defined with the directive, see, like this, define, and are invoked with the quoted macro names as shown in the example. The syntax is like this. The first should write like this whenever you are going to define the macros. So this is must. Then space, macro underscore name, text underscore string. This is the name of the file, text file, or string of text file. So this is the way you can represent the macro, define the macros. One is time scale, one more is macros. Okay, and one more is, third one is include directives. What do you mean by include directives? Include directive means include is used to include the contents of a text file at the point in the current file where the include directive is similar to the C plus whatever you can include some beginning, you can write the some including file, generally including header files. Okay, so like that you can do. So here is the syntax is include file underscore name, include space. This is the, don't forget to put this one. Okay, include space file name. So next one is come to the delays. These are very important. These are compiler directives. There are compiler directives, so that compiler will understand those things. They are not synthesizable. Okay, keep in your mind, they are not synthesizable statements. Okay. Uh, Now delays. The second one is delays. When it comes to delays, generally whatever the codes we are writing, design module, whatever you are writing, we are not including in any delays. We are not writing any delays. So the delays are introduced in the design module only. So in the design module, whatever the designs we did so far, all are zero delay variants. Zero delay. Zero delay. We are not given any delay. Zero delay. Zero delay. So suppose if you want to introduce some delay, generally ideal case is zero delay. That means whenever the signal is applied to a circuit, the output is immediately at the same instant of time you can achieve the output is called the zero delay. But this is ideally, it's right, but practically it is impossible, because if the circuit, so when the input is set to hit to, so then it will take some time to process it and it will give the output. So in that direction, in that scenario, so definitely every circuit is associated with some delay. Sometimes, suppose you are going to introduce some delays. So that we are intended to introduce some delay. Okay, then how can he or she can write the delays in the program? That we will discuss here. Sometimes what happens, why the delays are required actually? So delays are required to avoid the escaping of the signals. To avoid the escaping of the signals. For example, there are two circuits, they are connected in the parallel. Okay, the clock is same, you are applying, for example. Clear. So that what happened, the one circuit, first circuit output factor, the second circuit output input. Then what happened, if the, suppose if the circuit first circuit has more delay, okay, than the clock applied, then what happened, the second circuit will miss the first circuit output to take. Okay, so that at that moment, what happened, we can give some, what is that one, delay in the clock also, second clock also. Then what happened, the clock can be take some time to I think can be sensitized, either edge trigger or level trigger, edge trigger or level trigger, so that meanwhile the output of the first circuit can be fed to this one. So I think you have a one circuit in the in DLD, that is the problem of what is it, toggling action in the JK flip-flop. So if you consider the JK flip-flop, JK, whenever both J and K are is equal to 1, the output will be toggled, in the sense the output is changing continuously as long as the clock is available. That is, I think it is a floating. So it is a, you cannot measure what is the exact value at the output of the flip-flop. Okay, suppose the clock is this much duration. This is the clock duration. Okay, it is a 2 microseconds. 2 microseconds is the clock duration. So then within these 2 microseconds, whenever J is equal to 1 and K is equal to 1, so your output Q is toggling. Means if previously 0, then it becomes 1, then becomes 0, then becomes 1, then 0, 1. Like this, going on, changing. As long as clock is high, 2 microseconds. So this is the what? Unstable condition. Unstable. It is not stabilized at one. It is not stabilized at one value. It is going on changing continuously. So this is the issue of the JK flip-flop. To avoid the JK flip-flop, So I think we have a two solutions. One is the master slave, master slaves, and second one is the, so what happened? The delay of the clock, delay of the circuit, or the clock pulse should be less. This clock pulse, this TCLK should be less than, this is the PD. This circuit is having some propagation delay. So TPD, this is the condition. If the clock width is, the clock pulse is less than the propagation in the flip-flop, then definitely you can avoid this one. These are the two cases. Of course, you can avoid it. Okay, so that is the, in the means what we are changing the delay here. We are changing the delay here. So that sometimes the designer may be interested to change the delay, introduce some delay. Then how can he or she introduce the delay? In the program, how can you write the delay? Okay, we'll see now. Verilog gate delay specifies how values propagate through nets or gates. How values are propagate. Okay, how values propagate through nets or gates. With what value they are? That means the gate delay declaration specifies a time needed to propagate a signal change from the gate input to its output. So definitely, so the delay is nothing but how much time. Suppose I applied the input at 2 o'clock. So, and I am waiting at the output to collect the output. So, at what time it is getting? That immediately at 2 o'clock it is getting, or 3 o'clock, or 4 o'clock, or 5 o'clock. If 3 o'clock, 1 hour delay. If 4 o'clock, 2 hours delay. If 5 o'clock, 3 hours delay. Like that, what is the delay of the circuit? So that you can find. Yeah, the gate delay declaration can be used in the gate instantiation. So I'm talking about now delays, of course, no doubt at all. But gate delay, suppose whenever you are going with the gate level modeling, then how can you write that? How can you insert the delays? So generally, suppose if you have a five gates, different gates, the same similar gates, I don't bother about them. So one is not gate, one is the under gate, something. Then definitely we are using the instances. So that means, so and space instead number. So it may be a A1. So in bracket ports. Okay, so that is the way we are writing. That is the way we are writing. Now, okay, that is okay. So I will write once again here. For example, A and the and is the one of the gate. Okay, and its instance name is suppose N1 in brackets. Suppose it's a 2 input under gate. Okay, so A, B, and this is the Y. Then you can write Y comma A comma B. This is the way of declaration of the gate matrix. But this is the gate level statement. So now what I'm trying to tell you, suppose if you want to insert the gate in delays, in this case, how can you write? How can you specify? So use it for the delay control. So then we can write here. So A and the and in brackets you can write the delays, then write the instance name, then so ports you can write like this. This is maybe a 5 hash 5. Okay, that depends on the type of delay you are going to consider. Okay, we'll see what type of delays we are having. So what type of delays we can insert it. Okay, that we will do now. Yes, there are 3 different types of delays. One is the rise delay, one more is the fall delay, one more is the turn off delay. So sometimes you can go with the only rise delay, only fall delay, only turn off delay. Sometimes you can put all 3 different values, or they can be represented with one single value. So that is, so according to your design, you can change the delay values based on that the gates or the circuits can be takes the propagation. So based on that, the output will be what? So appear at the output, the signal output signal will be appear. Yeah, if you come to the rise delay, what do you mean by rise delay? It is equal to the time taken. How much time it takes to by a gate output transition to 1 from what values? 0 or X or Z. So I think we have a four variables, four values, four variables. What? Logic 1, logic 0, X and Z. Rise means 1. Okay. So suppose any signal, okay, at the output, okay, to rise to 1 from some value. For what? What are the out of four logics, four values? So one is already defined, 1. Remaining 3. From remaining 3, the transition takes to 1. How much time it takes is called the rise delay. Fall delay is reverse operation. To go to 0, output goes to 0 from either 1 or X or Z. One more is turn off delay. Turn off delay. So what do you mean by turn off delay? So turn off delay is what is it? It is the time required by the gate output transition to high impedance state from either 1, X or Z. High impedance state. That is the turn off delay. See, here is the pictures. They are representing the each delay. This is the rise delay. This is the fall delay. This is the turn off delay. So rise delay means from 0 or X or Z to 1. So this is the, see, here is the 0 or X or Z. So from this, it is reaching the 1 here. So this is the amount of time so required to fully rise to 1. And this is the amount of time fully fall to 0. And here turn off time is nothing but what? To the high impedance. Z is the high impedance. Z is the high impedance, either 0, 1 or X to Z. So that is the how much time it will take to what? High impedance, goes to high impedance state from either 0 or 1 or X. So these are the three major different delays that we can introduce in the program. So by that way, you can go to the design. That is called the, if you are not introduce any delays, that is called zero delay modeling. Suppose if you introduce only one unit of time, then it's called the unit delay modeling. So like that. So listen, the first example is here. And example, this is example. And is the gate, and the gate. This is the instant name. This is the instance name. This is the gate. So remember, so Verilog is the case sensitive, so that definitely use the lowercase letters. And these are the ports. What is this? This extra fellow is there here. This extra fellow is nothing but, this is extra fellow. This extra fellow is nothing but delay. As I told you, you can write the bracket like this. Dash, first rise delay, comma, fall delay, comma, turn off delay. Turn off delay. This is the way. But instead of 3, okay, all are separated with commas. Instead of 3, here is only 1 is there. That means hash 5 is there. It means, in brackets, it means rise delay is 5 units and fall delay is also 5 units and turn off delay is also 5 units. All 3 delay values are equal. That's value is 5. So that is the one type of representation. Another type is, suppose this is the gate primitive and this is the gate instance and these are the ports. Now here if you look at this side, so that represents the 3 values, 3 integer values, 3 integer values. Here, see, here is 3 integer values. One is 3, one more is 4, one more is 5. So first one is rise delay 3 units and fall delay is 4 units and turn off delay is 5 units. This is the another. Suppose if all the delays are not equal, not the same value or same amount of time, then we can write differently. So, and one more thing is this one. So, OR gate, OR primitive, and this is the instance. 1 minute. I will clear this. Yes. Yeah. So, OR primitive, this is the ports, and this is the instance name. And here, see, this is the time values, delay values. Here is only 2 are there. 2 are there. 3, 4. It means rise time is 3, fall time is 4. And what about the turn off delay? Turn off delay. So turn off delay is, there are 2 different values. Out of that, you should select the minimum value. So the minimum value between the minimum value of comma 4 is what? 3. So that's why turn off delay is 3 units. So that 3 comma 4 comma 4 3. This is the time units. Delay is 3 units, 4 units, and 3 units. Okay. Suppose if you forget to write about the turn off delay, then what happened? What is the minimum value between the rise and fall delays? You can select as the turn off delay. So there is another way of specifying the delay times in Verilog. So this is minimum, typical, maximum for each value, for each delay value. That means, suppose if you take this one, 3 values are specified, 3, 4, 5. Okay. So like first one, we already know the first one is rise delay, is 3 units of time. In case of rise delay, you can write 3 values. Okay. Similarly, in place of fall delay, you can write the 3 values. In place of turn off delay, you can write the 3 values. So those 3 values in each category, the 3 values are separate with the what? The semicolon. Sorry, not semicolon. Yeah. For example, for this one is, see here. Example of this one is first statement, you can check it. And of course, this is a AND gate. And underscore 1 is the instance name, and ports out and in 0 and in 1. Okay, let it. And here is the delay is specified here. 4, 5, 6. 4, 5, 6. But 4, 5, 6 are, see, they are not separate with the commas. They are separate with the colons. They are separate with the colons. Means rise time, fall time, and what is that one? Delay time. For all are equal. Okay. For each delay, okay, for each type of delay, the minimum value is 4, typical value is 5, and maximum is 6. Minimum delay is 4 units, maximum delay is 6 units, and typical value is 5. So that is the way of representation. So whenever you are going to write minimum, maximum, and the typical values, you should not separate with the commas. You should separate with the colons. And the next one, see, the 3 values are specified. Here is different values, of course. See, 3, 4, 5 belongs to the rise time. 4, 5, 6 belongs to the fall time. And 5, 6, 7 is, of course, turn off delay. So each category is having minimum, max, and typical values. Okay. In the above example, if the designer choose typical values, then the rise delay is 4, fall delay is 5, and turn off delay is 6. Okay. So see the 4. What are the typical values? Middle values are the typical values. 4, 5, 6. 4, 5, 6. Yes. I think these are the delays. The syntax of these are the how to add the delays, how to include the delays in the gate level modeling. When it comes to the behavioral modeling, then where there I think you could not find any gate primitives, so that where you can find the assign statement. So where how can you write the or how can you add the delays? Yes, of course. In that you can find only assign statements. You can write delays there. See, example here is example. Write the assign. After that, write the delay. Then left hand side variable is equal to right hand side expression. What first right hand side expression will be evaluated. Whatever the value it finds or evaluated, that value is assigned to the left hand side variable with the delay what you specified in the statement. The syntax is assign space delay. Okay, letter. So left hand side variable or left, which stores the value or which assigns the value is equal to right hand side expression. So the right hand side expression will be evaluated first. For that right hand side expression, we need the inputs. So based on the input values, it will be evaluated and the value is assigned to the left hand side net. So after immediately evaluation of the right hand side expression is assigned to the left hand side net or not. That depends on the amount of the delay you are introduced. If not introduced any delay, that is called the zero. That means immediately once it is expressed, the expression is completed, so then it is assigned to the net. Suppose if you given any, if you specify any delay, after that time only it can be evaluated. Okay. This is one of the example. Generally, we write assign statements like that. Assign output is equal to, so input 1 ending with the input 2. Maybe it's a ending means what? So it's a AND gate. It's the AND operation. AND operation. One input is in 1, another input is in 2, and output is out 1. So the Boolean expression for this one is out is equal to in 1 and with the in 2. This is the here. If you see the statement, there is no delay value. Means it is a zero delay statement. Suppose this is another statement. It's another statement. It is also zero delay statement. Now see this statement. Assign as to z of 0 is equal to some expression is there. So forget about this expression, whatever this expression. So first it evaluate this expression, and whatever the value, okay, getting after evaluation of this expression is assigned to the z of 0 after 2 units of time. After 2 units of time. So this is the delay here specifying. Yes, this is another thing. 1 minute. Yeah, if you take this one, assign as 10 out is equal to in 0 or with the in 1. Input 0 or in with the input 1. So this is the OR gate. Okay, first take the input 0, whatever the value from the input 0 and input 1. Now both are ORed, logically ORed, and whatever the value, so results, that value is assigned to the out after 10 units of time. So this is called the regular delay models. Regular delay models. So another one is, see here is, I wrote a statement of while as 10 out is equal to, so of course this is exclusive OR operation. So between the input 0 and input 1. So first to calculate the XOR operation, do the XOR operation, and okay, and the value is given to the out with the delay is specified. This type of assignments are called the implicit continuous assignment delay. Implicit continuous assignment delay. In this statement, see, if you observe closely this statement, in this statement, you could not find any assign statement, assign keyword. Okay, so that these are called the implicit. That means by default, I think so. It is hiddenly it is there. What assign is there? You can write this statement like this also. Yes, while out assign as 10 out is equal to exclusive OR of input 0 and input 1. Yeah, same statement, the single statement you can split to, because I already stated that the statement is nothing but implicit continuous assignment delay. Implicit means hidden continuous assignment delay, but you could not find so any assignment keywords in that line, in that statement. So that statement is equal to the, so like this. What is this? While out, then assign as 10 out is equal to exclusive OR of, so input 0 and input 1. So one more thing is, while as 10 out, assign out is equal to in. This is the net declaration delay. So first one is regular delays, second one is implicit continuous assignment delay, and third one is net declaration delay. So what is it? While here also as 10. Okay, so while is what? That is the net generally. While is net. Okay, as 10. We are declaring the delay at the net only. So that while as 10 out. So then you can write the assign out is equal to in. This is the net declaration delay type. This can be written as like this. These statements can be written like this. What is that? While out, like previous, while out, Okay, then assign aston out. Both will give the same results. There is no difference in the output. So this statement or these statements, these two statements, whatever the output, they produce the same output they can be provided. So both are functionally equal. Both are functionally equal. So that is the syntax of what delay in the delay introduced in the what data flow modeling. So in the data flow modeling, you can find only assignment statements or while or something, so that you can write if with any statement or you can insert the delay in the any statement in this fashion. Yeah, of course. Now come to the point. Already here is I am going to show you that 2 to 1 mux. Of course, we already done this. Okay, so see, these are the statements. Yes, A0, A1, Y are the output. These inputs, and these are the what inputs, and S is select line, and Y is the output. You know, inputs okay, output okay, and this is the what conditional statement you can write. Ternary statements. Okay, so means there are three operators and three operands and two operators. So S question mark A1 and A0. So means if this S value is 1, output is A1. If S value is 0, output is A0 and module. So you know this is the 2 to 1 mux in the behavioral modeling because there is the assignment statement keyword used. So that's why. So by default we can say it is a and it is moreover it is a depends on the what. Yes, this select line, so that you can say this is the data flow model. Okay, so now take this. This is the of course text benches. The text benches like this. Top module is inputs. All inputs are registers. Output is wire. No doubt these things okay. And S is equal to 0. Whenever S is equal to 0, begin S is equal to 0. Okay, this is the A1 A0 is in the curly brackets. This is called the concatenation. Concatenation. This is called the means together. Whatever the value I specifying is nothing but A1 and A0 value. So concatenation. So is nothing but togetherness. A1 A0 is equal to 0 1. It means A1 is 0, A0 is 1. Okay, after, so this is the delay. Of course, in the what is it one? The time scales are already introduced in the test benches, but in the design modules we didn't use it so far. So that now we discussed about only the delays. So now we can write the designs including the delays. Okay. After some time, maybe 10 minutes of time, so change this S value as 1. Now the concatenation of A1 and A0 is 1 0. Okay, so then, so this is the test bench, of course. Okay, this next one is 4 to 1 mux. 4 to 1 mux. Of course, 4 to 1 mux means 4 inputs are there, 2 selects are there, one output is there. Here is the select, two select lines. Yes, 4 inputs. Yes, and one output exactly. Here also I use the conditional statement like assign y is equal. This is the delay. Y is equal to first. See this one. What is this? Yes, double equal to 0 0. Double equal to is nothing but the equality operation. Is equal to only single equation is there. Equal equation is there. Single equality is there. That is called the assignment. Okay. Yes, double equal to 0 0 means so as your select lines are equal to 0 0. That means S0, S1, S0 are 0 0. Okay, then what is it one? Output is A0. Okay. So otherwise what happened? Otherwise, here is two things are there. One is the this is one means this will be continuous, or means this will be express. Okay, S0, S1, S0 are there. 0 0, 0 1, 1 0, 1 1 is there. If 0 0, A0 will be the output. So The next one A1, next A2, next A2, like this. Here first it checks this condition. If 0, 0, if 0, 0, true. If it is true, the statement is true, then output is A naught. Okay. Otherwise, checks this one. Okay. Is it 0, 1? Then output is A1. Okay. So if it is this one, then A2, otherwise A3. Then one. Of course, this is the simplest code, which already we use this code for the implementation of 4 to 1 mux. Okay. This is the using of conditional statement. This is the condition. This is the condition. If this is true, that one. Okay. So next one is this is the what text fetches. What is that? Initial begin. Of course, the top some statements are there that I don't want to write and getting bored you. So this is the first statement is suppose select line yes is equal to 0, 0. Then concatenation of concatenation of all inputs is equal to 0, 0, 0, 0, 1. Okay, so that is first thing is S is equal to 0, 0. First, we are given S is assigned with the 0, 0. Select lines are 0, 0 now. Now, all the inputs are values also specified. This is justified. That's why it must be specified the input values. So the input values are concatenated as 0, 0, 0, 1. Next, with this input, with the some time delay, S value changed to 0, 1. Again with some delay, S value changed to 1, 0. And again with some delay, this is right. It means what? Whenever you write the time slots like this, in the serial, because initial we are using initial this one, so that what happened? The time slots are get added. So, and suppose you are assigning the S value 0, 0 at t is equal to 0, okay, and you are assigning the S value, or you changing the S value from 0, 0 to 0, 1 at t is equal to 10 seconds. 10 seconds or 10 seconds, whatever the time you consider. Okay, then S is equal to 1, 0. You can change with addition of all this time. First time is 0, second is 10, third one is 10. 0 plus 10 plus 10, 20. At t is equal to 20, I think your set values are changed to 1, 0. So that is the way. Next, inputs are again changed. So that is the way you can write the test bench already. So we completed this one earlier, so that I'm moving fast. Here earlier, the 4 into 1 mux, 4 to 1 mux is implemented with the conditional statements. Now, so I'm going to implement with the if and if then else statements. Yes, this is same, everything is same up to here. Now, always as 3. If S double equal to 0, 0. S double equal to 0, 0. Suppose select values, select lines is S1, S0 is equal to 0, 0. Then what happened? Y is equal to A naught. If not, else. If, then else. Again, check one more condition. If it is true, output is A1. If not, go to check another condition. That is this condition. That is it. So if all are wrong, then finally one condition is there. That is the so else y is equal to A3. This is the if then else statements. Here you need to understand or you need to identify one thing, that is this one. What I wrote here, always as 3. Delay is introduced here. This is the behavior modeling where the delay nicely added to the always block. Okay. So with the amount of what is the delay here? 3 units of time. 3 units of time. I don't know the units. Okay. So whatever the units you can write on the top of the design module, that it will take automatically. This may be nanoseconds or picoseconds or seconds or microseconds or milliseconds. So whatever the value, the units is specified, that amount of the delay is introduced here. So already constant integer value is 3 units. You need to specify. Yes. In the always statement of our this 4 into 1 marks. See, here. I'm talking about this one. We actually asked Verilog to reevaluate the output every 3 nanoseconds. Always as 3 means, so the outputs, that means these statements, all these statements in the always block should be evaluated after every 3 nanoseconds, after every 3 minutes of time. So that output will be, so what is calculated or displayed after every 3 minutes of time. Because the 3 is you are added to the always, same line. So for every 3, suppose here is certain time units or nanoseconds, so that every 3 nanoseconds, so this program will be, this block will be executed once, and output is value is assigned, new value. See, here is the same statement I wrote like this. The same thing I wrote like this. What is this one? Always at the rate of yes. You know about s. S means only what? Select line. So whenever the select lines or changes, select lines are triggered from one value to another value, this loop should be, this block should be executed each time. So when the, what's that? So each time when the select lines are changes, this loop should be executed. So here I wrote as 3. That means the delay is written here. That means the statements, whatever written here, so they are so taking the 3 minutes of time of delay. So that is the this one. So the same program, the same 4 to 1 marks, you can write with the, you can implement with the, what is it one? Essence statements, and one more is if else statements. Then one more is what? In the if else statement, and the type is same if else statements you're using, but here is what happened. You are not taking about any sensitivity list, but here is I take the sensitivity list is as select lines. And one more type is, see this one here is always at the rate of all the variables. I'm not taking the only one variable. So earlier I took the, in the sensitivity list, I took the only select lines. Now not only select lines, maybe the input values. Each time either select lines or input values are changes. So these statements should be executed each time when they are sensitized, when they are changes, when they are triggered. So these lines will be, these statements in this block, always block should be executed. So here is, see the delay is written here. So that is the way of changing the, so suppose if you execute these 3 programs, so then you can find the difference. So what difference you can find? So the delay difference you can find. In what way the delay is, so in this first type and second type and third design, so changes. Yeah, one more is multi-way branching. So multi-way branching is nothing but, you know already. So we did number of programs. Okay, using of case statements. Here is say, so case S is the case expression. All these are the case statements. This is the case expression and all of the case statements. Okay, default value. Sometimes we need to write the default value. Suppose other than, so in some S value, you are talking about the S value. S value is 4 to 1 marks. That means S value is 2 bits. It may be 0001, 0001, 1011. You are talking about only 4 combinations. Why don't you take 0x or 1x cases, or x1, x0, x1 or x0 cases? So at that time, so what happened? So you can take default value as display unknown select value. You can type like that. Whenever you find the select values are 0x or 1x or x0 or x1. Okay, so at that time simply it displays this statement unknown select value. So another thing is quasi, this is the multi-way branching. And one more is quasi-continuous assignment statements. The same 4 to 1 marks, I am writing in different ways. Here is same, always yes, case, expression, and all are these are the case statements and same thing. What difference here and here, here and there? So here is the quasi-continuous, here is the multiple branch. In quasi-continuous, see here is, I am talking about quasi-continuous or procedural continuous. I am using assignment statements here, once again here. So the evaluation of the case expressions, case statements are different. Okay. So I think now it's time is over. What is the use of this display? Display is a system task that displays the string in its argument. Whatever this is the argument. What is in this argument? So unknown select that will be displayed whenever it finds the default value. So other than whatever the combination you are assigned. So there is 4 combinations you are assigned. Other than these combinations, if any other combination is suppose by default or unexpectedly it comes, then what happens? It displays this statement. So that's why the display statement or what is this display system task? The system task display is a system task that displays the string in its argument. Okay, so that is students. Hello, students.
Yes.
Yeah. So are you understand?
Yes, sir.
Yeah. Today class we talked about the compiler directives. In that, the first one is what? Time scale. That is very important. So later 2 things are not important. Then that is the define, and one more is another one. And later delays we have discussed. The delays are 2 types of delays. Okay. So mostly all the designs must be associated with the delays. So no doubt at all. So far we are not talking about any delay. So because first of all I like to learn the topics without any difficulty. So that is the way, that is the intention. So that now it is a time because we are going to edge of the all the levels of abstractions. So that I'm going to introduce now the delays. So definitely practically delays must be there. So that designer need to intentionally need to add some delays. So there may be different types of delays: rise, fall, and turn off delays. So I think if single value is specified, so I think 3 delays are equal. So different values specified means each you can assign. The order is rise, fall, and turn off. So each delay you can be again assigned with the 3 values like minimum, typical, and maximum values. So the way of writing the delay in the gate level modeling or in the behavioral modeling. So there are 2 different things I already explained. So now behavioral level modeling. So generally delays are introduced with the always block, either in the always statement or in the next statements. So that depends on that. So we will do the programs with the inclusion of the delays in the next class, next lab. Okay. Got it? Hello. Sia,
Yes, sir.
I understand.
Sir.
Chepandi.
Yes, sir.
Understand? Sia.
Sir, yes, sir. Understood, sir.
Yes.
CR పిలుస్తున్నారయ్యా సారు.
In the next lab, we will do this programs with the inclusion of the delays. Okay, understand? Motivate your friends.
Sir, okay.
Okay. So and Wednesday, I think Friday you have an exam. Friday.
Sir.